Okay, let's continue on now looking at lists. So lists are a different type of container class, kind of like strings, but a little bit more versatile. And that's because they can hold any number of different types of objects. So back into the Python interpreter. And the way you create a list is using the open and closing brackets. So you remember that the way you create a string is with implicitly creating a string is with either single quotes or double quotes. But the way you implicitly create a list is using the brackets. So numbers, we can see it's the class list, and we can see that it has a different set of attributes and methods. So we have created an empty list right here, but we could always create a list by specifying it like this. So here we've created a list of numbers. So we've separated each element by a comma. And so we have a total of 7 different elements within this list. And again, just like string, you can use the length function in order to figure out the number of elements in a list. And that is similar as using the magic method. That is the attribute, the method of the list class. And that gives you the same thing. We can also slice in exactly the same way. So if we wanted to get a very specific element, we can do it that way. So this is the first element, this is the last element, and then this would be the 4th element. So Python is indexed starting from 0, so 3 indicates the 4th element right here, which is why you get the 16 back. You can also get multiple ones, just like before. And if you try to access something that is longer than the list, then you get an index error, which indicates that your index is out of range because there's not a 10th element of the list. There is a add magic method to lists, and so that means you can use the mathematical plus operator. And so how does that work? Well, this is pretty similar to concatenation. So if you take 2 lists, so numbers is a list, and now we've added a second list together, we see it concatenates the 2 lists together. So if we wanted to assign it to numbers, so now numbers is a list of 10 elements. One thing that's different about lists than strings is that you can actually modify lists. So before when we tried to do this with strings, we got an error because strings were immutable, but lists are mutable. So you're allowed to change the elements of a list. So we'll change it back. There are methods of numbers that you can use to also, so here, let me do this right here. So if we wanted to add an element like 5 to the end of it, you can only add 2 lists together. And so this again is the same as doing something like this. All right. So let's say we wanted to add a single element. So there's a couple, or we wanted to add a list. So another way you can do that is using methods of the list class. So let's see what our methods are. So one of these is extend, and the other one is append. So you're most likely confused what append versus extend is. But if you want to add a single element to the list, you use append. If you want to add multiple, if you want to add a list to a list, then you use extend. So let's see how that works. So numbers.append. So if we wanted to add the next in line, so these are just the perfect squares, 1 squared, 2 squared, 3 squared. So 10 squared, so the next one would be 11 squared, which is 121. And so we have now added 121 to the list. So there's actually a key important difference to how this works. So let's also do extend to show you something very similar. So we could also extend and add the next 3 elements if we wanted to. So 12 squared, 13 squared, and 14 squared. And so you notice append took an integer as an argument, extend took a list as an argument. And so that is the difference between append and extend. Append adds a single element, whereas extend adds multiple elements, and they all have to be wrapped together in a list. And so we've implicitly created the list by using the open and close bracket. So there's also an important distinction between how append and extend work. So and the addition operator. So we saw before we could do something like this. So 13, 14, so 225 to actually what is 16 squared? 256. So we could also do something like this if we wanted to add the next 2. But you'll notice numbers is not actually modified by doing the addition operation. So numbers plus these next 2 creates a new list that you could certainly save into numbers. So if you wanted to save it, you could do something like this and use the assignment operator in order to make that new total vector there. But if you don't do that, then numbers isn't modified. Numbers remains the same. But numbers.extend, it doesn't return a new list. All it does is modify the current list that you're acting on. So that's an important distinction that you should remember, is that when you use extend, you're actually modifying that source object permanently. Whoops, extend, and if I spelled it right, there we go. So now we can see we've modified numbers permanently. What are some methods that we can use on that besides that? So there's a couple other useful ones. So reverse and sort are 2 interesting ones. So numbers.sort. So let's do numbers.reverse. So this is a method, and so if you don't use the parentheses, then you get that printout, a built-in method. So now let's see what happened to reverse. So you notice that nothing returned, but again, we've modified that list in place. So the actual numbers object is modified by running this method, and so we've reversed the order of the list. And we could do it again, and you can see you can kind of keep on doing it over and over again if you wanted to. You can also sort a list, and again, that is in place. So you've modified the numbers, and now we've sorted them by the least to most of this. If you wanted to remove a certain element, so let's say I wanted to remove the 16th, so I need to know the element of that, and so this is 0, 1, 2, 3. And we are going to save this as x. All right, so what did this do? So x equals 16, so we popped that element off the list. So 0, 1, 2, 3, so 16 is the third. And now if we look at numbers, we no longer have the 16 in place. So the length of numbers has actually changed. So pop is another function, another method that actually modifies the source list, but it also returns the value of it. So we've given it the index, and then what is stored is the value of the element, whatever that object is returned as x. We can also clear the list, and now we have removed every single element from the list as well. Let's reassign it. Numbers.remove. So in this case, you give it a value, and now you notice that the 64 has been removed from the list. So remove is a way to remove things with a specific value. You could also, for example, delete, use this right here. I don't really recommend doing this, but this is another way to modify a list. is by using this del command right here. And you can actually remove multiple elements at the same time using the slice. All right, so lists are kind of like strings, but now we see that we can have a number object, for example. And another thing that's important to know is that you can also mix and match different types of objects within a list. So what do I mean by that? So this is totally legitimate, and so you'll notice if I want to access that first element, it's an integer, second element is a float, third is a complex, and then the fourth one is a string. So you can also have mix and matches, and you can even, for example, have one of the elements be another list. So the fourth element is a list, and you could actually, if you wanted to, access it sort of like this. Like this. So what did I say? I said, okay, go to the fourth element of the numbers list, and so that's right here. And then we can string together these bracket operators in order to say, okay, now look at the second index, which is the third element of that list, that corresponding list, and the 0th element of that corresponding list, and so that's why it returns a 2. So if you have a list of lists, then you can access individual elements of that by using this double bracket notation. All right, so one thing that's really weird about lists at first is that when you make a copy of it, so let's say you might want to make a copy of it and say, okay, numbers 2 equals numbers. And so numbers 2, and so it looks like we made an exact copy of that first list. So everything looks really cool. So now what happens if I modify this list? And let's do it by changing the first element to A. All right, so what did I say? I said take the first element and replace the 1 with a string, an A, and lo and behold, it has succeeded. But if I look at numbers, that first list, we see that it has also been modified as well. So this is something that's a little bit strange at first, is that in order to save RAM in your computer, in order not to use too much memory in your computer, the default setting is for Python to create what is called a shallow copy of a list. And this isn't true for other classes. So let's say we have x equals 2, y equals x. So we have y, x, and y. Now we modify y. So we notice y was modified by this, but x was not. And so this isn't something that's like universally true for like all of the different types of objects. This is kind of specific to the lists. So if you want to actually create what's called a deep copy, so we have numbers, we have to use this method called copy. So numbers 2 is exactly the same. And now let's see what happens when we modify numbers 2. So we modified numbers 2, but we notice that the numbers list wasn't modified any longer. And so that's because we used this copy. So this says don't just create a shallow copy. This tells it to create a deep copy and make a brand new list for every single element. There's also some functions that work on lists. So here we created a list of numbers again. So sorted is a built-in function, and you can call it and give it a list. And so you'll see that what sorted returns is a sorted value of the list. So now the smallest element goes first, and then the second smallest goes second, so forth and so on. But again, you'll notice that numbers, the original one, wasn't modified. So this is the difference between numbers.sort, which is a method. This will sort numbers in place, whereas if you use the sorted built-in function, it doesn't modify numbers, it returns a brand new list. You can also, for example, do this on letters. So let's say you have a set of letters that are within a list, and you wanted to sort the letters. You can also do that. And so that's because the string has this built-in ability to compare which letter is first in the alphabet compared to the other one. And so because the string class has this built in, we can talk more in detail in kind of the class discussion if you want about how exactly that works. It's actually able to also sort a list of characters. But what happens if we have something like this? Numbers 2. So we have a mixture of different types. What happens if we try to sort this? We get a type error. And so that because Python has no idea how to compare different elements. Sometimes Python is unable to compare different elements. So in this case, the error we get is that it doesn't know how to compare a complex number and a float number. So it doesn't know what is larger. Is 2.0 larger, or is 3 plus 4j larger? And the same thing would be true if we had a mixture of strings and numbers. So again, we created 3 elements that are the string type. We use the implicit way to declare a string, and then 3 integers. And so what happens if we sort this? We get an error, and that type error, what it's telling you is that it doesn't know how to compare integer and string. It doesn't know what is larger. Is an A larger, or is a 2 larger? And so that's where the error comes from. All right, one final part of list that we will talk about here are called list comprehensions. And these are actually incredibly useful, but a little bit difficult to learn at first. And so it is definitely worth the effort in order to memorize exactly how to use a list comprehension. And the idea is that for a list comprehension is that you might want to modify all of the elements of a list in a certain way. And so if you wanted to multiply each one of these by 3, you could perhaps, maybe you could do something like this. But that's not how the multiplication works. So numbers times 3 doesn't multiply each element times 3. What it does is it appends the list 3 times in a row. And so that was also how kind of a string works. So let's say we wanted to multiply each of these numbers by 3. And so what you can do is something called a list comprehension. And the syntax looks like this. So 3 times x for x in numbers. And so now we see it does exactly what we want. So 1 times 3 is 3, 2 times 3 is 6, and so on and so forth. So all 5 elements were multiplied by 3. So this part right here specifies the last part of this. So one of the things you notice is that we have the implicit list constructor. So this says create a list. And the last thing that we put in there is the name of the list we want to modify. So we could specify this as numbers. We could also specify it as letters. And then the next thing we need to write is this for. And what for says is that for every single element in letters, and we give it a name. So this specifies the name of the element. So for x in letters. And so now we get an error because it doesn't do it. So we could do, for example, x for x in letters, and now it works. And so what it says is that, okay, go through every single element in letters, and we'll call it x. And so what did we do here? We just said, like, leave it alone, just do it as x. But we could have also done something like this, and we could have modified each element. So this right here is the logic for how exactly we modify it. So 3 times x for x in letters. And now we see, okay, so a string, we have a string, and if we do 3 times a string, it concatenates it 3 times in a row. And so for this, we've modified it from an A, G, S, C, Z, F, X to triple A, triple G, triple S, triple C, etc. We could also do something like this. So we notice that we first take x and we use, because this is a string, we use the method upper on it to convert it from a lowercase to an uppercase letter, and then we use the concatenation in order to put those 3 letters together. We could also do something like this. So now we've taken this string, hello, and we concatenate the uppercase of each letter. And so now each element is equal to hello A, something like that. You can choose to call these whatever you want. So for example, if I wanted to say for Z in letters, that just means I have to modify this part of the list comprehension so that instead of using X, I use whatever name I called it in here. So you don't have to call it Z. You could do something like this. You can call it letter for letter in letters, and then you basically have your variable that you can do that way. So and then you can finally even do something goofy like, let's say like this. And so now what we've done is we've taken this and we've run sorted on it, and so it sorts each one by the letter, and then it creates a list out of it. So if we did something like sorted hello, it basically returns something like this. So as you get used to chaining these functions and methods together, you can start to do very interesting things, and you can really have a lot of control on how to modify a list kind of however you want. So hopefully that makes sense. If not, we can certainly talk about it more during class time.